Okay, in this one you're going to have to brush up a bit on your trig, right? So there is a unit circle I did put down here that you're going to want to look at. I'll refer to it. So in this problem, it's a simple derivative, right? So this is just using our derivative of trig. So what we're going to have is y, oops. What we're going to just do is y prime is equal to, well, the derivative of sine is just cos x plus 1/2. This is going to be chain rule, so this is going to be cos 2x times 2, right? So then really rewriting this expression would just be y prime cos x plus the 2's cancel, so we then have cos 2x. So you want to remember here, that's a double angle. Double angle formula. These are in your formula booklet. Okay, so that's going to be in the formula booklet. So what am I going to do with this? Well, this is y prime is equal to cos x. I'm going to use it to my advantage because we're going to use the first derivative test here. So there is a formula booklet, so you can check it. You would actually get 2. This is, so the cos 2x is actually equal to 2 cos squared x. I think it's minus 1. Yeah, minus 1. Minus 1. And of course, we're going to set y prime equal to 0 because that's going to give us our critical values, right? So when we have then cos x plus 2 cos squared x minus 1 equals 0, we'll take a look at this. Just think of let cos x equal a, right? So if we do that, you then have 2a squared plus a minus 1. I can easily factor that. So that's just 2a. This will be minus 1 plus 1. There you go, done. So let's just double check. This times this produces this. This times this, it's a positive 2, but minus, we'll get plus a. Okay, so that works. 0. Therefore, I just reintroduced what cos is, or a is. So it's just cos x minus 1 equals 0. That means cos x is equal to 1/2. Or it's going to be cos x plus 1 is equal to 0. Cos x is equal to minus 1. Well, now we just need to consider what on the unit. So you need to remember, recall unit circle. Unit circle. Right? And then those special triangles, right? 1/2, right? This would be root 3 over 2, 1. What's going to be helpful is a quick reminder is using this. So you want to use this as your unit circle, right? So this is pretty important. I'm going to use that. Just notice where 1/2 is. So remember, it's always cos x sine x. So your x values are your cos. So look at that. There's 1, and there's the other 1/2. So those are the 2, but you can see that that's your another right angle triangle, right? So that's your from your equilateral triangle. That's what you're actually probably going to need to remember in the and be able to construct in an exam, right? This is a helpful little tool to get you to the hump using your special triangles. You can ask questions about that in class. I definitely recommend asking that because it's just a refresher all the time. And it's good to catch up right now. So right there, you can see that your 2 angles are right there, pi over 3 and 5 pi over 3. So you know pi over 3 and 5 pi over 3. And then there's only one place where you can get -1. There it is. So that's just going to be pi. So we can draw, this is going to be pi. This is going to be pi over 3. Oops. And this will be another 5 pi over 3. So what you can do is then you test points. So if you test a point of, like, let's say 0, so just put in for your prime 0, that'll be positive. If you do this with other subsequent points, so f of x, whatever x you put in, so right here, this is my pi. Right here, you know that peak, because it's a 0, you know that's pi over 3. And you know this one is also your 5 pi over 3. So you can actually see right here where it's going to be. So I'll choose a number, any number you can think of, like the angle, right? It's like 3 pi over 4. That'll do it. And you put it into your calculator, or you'd have to do a long calculation and just, you can get a positive. Remember, you're just caring about a positive number. So it would be minus, then you would have minus again, and then positive. So what you would then see is, oh, okay, so this is up, down. So this is max. And then right here, it's a stationary point. So stationary point, stat point. And then right here, up, and this is your min. So there we go. We have various curvatures figured out, right? And that's how you'd be able to do that problem. Fairly straightforward. But you're ultimately going to need to remember, brush up on your trig. And that's where we're at right now. So if you have questions, just ask in class and I can go over it again.